Hello everyone, this is Singer. In this video, we'll have a brief review of sine, cosine, and tangent and their relationship, and also a brief walk through the unit circle, why it matters and how it works. And the most important part is to explain the logic behind it instead of just throwing with some concept and stuff. So in the first part, let's just look at a sine and cosine. And this section I have the values, so this is basically the data points, so we can maybe just select the cosine and have a look at the sine. In the sine I have a highlight using different color at this area because this represents the y value at 1. This plot is actually using the x, the angle in degrees as the x. That's why you can use a single like a sine value. In previous I used the sine and cosine to form a whole circle because we are not using the degrees as the axis. On the contrary, we are using x and y. X is represented by the cosine value and sine value is represented by the y value. So in this case we are using the degrees as the x and the sine as the y. So that's why you can see at the 90 degree at this spot you have a yellow dot. I don't need this section, so it's a little bit just overlap on top makes it obscure and a little bit difficult to see it through. So at 90 degrees we have a 1 and a y value, and this is y. It uses the x-axis is pull out this degree as its x coordinates, and then y is corresponding to this value, this is sine value, because now we're looking at the sine. It starts of course at 0 and then bump up to 0.26 and then reaches to half of the, in the middle we're meeting 1 and 0, so then it's 0.5 and then gradually like ramping up in 0.71 and 0.87 and gradually finally this is a pretty close 0.97 and finally 1, and then gradually decreasing in value is like reaching the value at this point. And so we can just give it a little bit flavor, maybe just fill with a pink color so you can see 270 this degree we have a negative x value. So it's pretty much the same for y, it's just the difference I'll explain to you later. You can see the cosine is actually starting from 1, it's now starting from 0, and it has like a gap, 90 degree gap. That's the difference. Here you already have, and here it has 0 and here it has 1. This is sine and cosine, so you can manipulate by using the cosine or by using sine. If you add 90 degrees in to form another curve, and then it definitely overlap with this one. I'll show you later on. And then I guess the other part, as long as you have input, you can manipulate it by clear the content. You can check out, so for example here we can also just clear the content in those spots. This is the sine, cosine. Oh, this is cosine, starts from 0 and dropped there. I know it doesn't matter because we're not cutting at the 90. We should for better illustration I shall clear the data points at this spot exactly at 90, and then we can just clear out the beta points. You can see this is a sine is starting from 0 here, and then you gradually bump up to 1 at 90 degree. Here's 90 degree. However, if you are looking at the trajectory of the cosine, it starts at 0. When sine is at 0 and cosine, when the degrees is 0, is actually 1. So it's like decreasing, and drop to 0 at 90 degree is like reversed. However, for this plotting effect, the number of points in between, you can use the interval to decide it. Maybe you want to be a more tighter one, and you have 10, or you have an interval of 5, then it definitely changes. You can have like this, maybe just a little bit cluttered like this. You can have your own design and make it work visually, or anything that makes sense to you. So this is the sine and cosine, and the effect can be manipulated using the interval. I just demonstrated, and then we move on to the tangent. Tangent, you can see, is clearly a little bit weird, because the relationship is, oh okay, there's a typo here. I just removed the G at the end. Tangent equals sine as the numerator and cosine as the denominator. So that's why at this spot it has enormous value. It's like a exorbitantly high value. So you have even if, for example, this is I just want to do a little bit of demonstration. I bump up the value to extreme. You just see vertical lines, yet it's not touching it. It's just approaching asymptote. It's approaching the vertical lines at this spot. So I guess tangent, we cover it. It's like, you can check it at 90 degrees here. It's approaching. It's not. It's like just like a infinite, the concept. So then we move on to this spot, because we have y is sine over cosine. We can analyze the logic behind. It's basically the Pythagorean triangle theory. You have the opposite. If you have a sine theta, then it's opposite as the numerator, and the hypotenuse as the denominator. This is the fractional relationship. And then you move on to the cosine, then you have a opposite. Oh no, this is actually, I have something that is not correctly laid out. Adjacent should be adjacent as the numerator. The denominator should be hypotenuse. That's right. So we just correct it. Anyway, this relationship is pretty fundamental, and we covered it. The magic part is that if you drag this triangle, the right triangle, and put it inside a unicircle, then the hypotenuse becomes the radius. The radius is 1. That's why it's called a unicircle. So then we can do a little bit of substitution. We can just stick 1 there, and stick 1 there. Yeah, that's about right, because it's a unicircle. The hypotenuse equals 1, is the radius is 1, so then it becomes simpler. At this point, if the denominator is 1, you just you can erase it, the entire stuff. You can just put adjacent and opposite. We don't need the hypotenuse, because hypotenuse is indivisible. Just 1 as the denominator below the fractional bar. So it becomes like this. So actually this part is a bit let's just make sure it is consistent. We need to put a fractional bar here. The tangent originally is just the opposite over adjacent, so like this, and then since we replace it, we can put some stuff inside it. This of course is a cosine theta, and this one is sine theta. At this point, this is the way how it's derived. You have a identical one because we just substitute everything, and the radius equals hypotenuse, and a unit circle equals 1. Then simplify the equation, and then substitute it becomes this, and then this way you have a 1, and over 0 is like an infinitely just enormous, gigantic value. So this is how the formula is generated, and then we can have I need to first just deselect some stuff here. Earlier I talked about sorry, I didn't seem to take effect. Earlier I talked about if you take the sine value and then somehow you add a 90 degrees, because the relationship between the sine and the cosine is the sine reaches a point which reaches 1 at 90 degrees, however the cosine reaches 1 at 0. So if you add this amount, if you add 90 degrees, which is the span of this area, and then it becomes the cosine. It's overlapping, so we can just check it out quickly. First we just check the cosine, and then you have a look at it. It's like this way, because it's a little bit flat. I just need to adjust it. Maybe this is becomes better visually. So this is it, and then we can turn it off by uncheck this box. So later on, we just for a double check this box. So this one, I just because there's a supposed to be a label area, it's like a legends reads those stuff here, the headers. Just because the real estate in the screen is tiny. Just if you have a giant labels with the legends, then it comes clustered. It just obscures the view, so I removed it. So we just demonstrate that if this is actually we can do a in-depth check. It's not a cosine, however it overlaps the cosine because it's supposed to overlap the purple one. However, even if you turn on all the headers and the data, it still won't show because it's overlapping. However, we can check it. Here we use the cosine. This is correct. This is sine because we're not referring to the radian. In this spot, we're moving shift a little bit towards the left. Another column. In this column, we added 90 degrees first, and then turn it to use the radian and turn it to like a more associated with the pi. So move on to this spot. The curve is overlapping with the cosine. So I check this one, and we can first maybe check about the altitude. Amplitude is the height of the curve, and this one is out of proportion because we just cut down, truncated the y coordinates down to 2, so we need to bump it up to 4, and also the negative side we need to keep it consistent, so also give a -4. So afterwards, if we increase it, it becomes clear. Maybe just for a convention, we should not give the exact value to the top limit. We should have a little bit wiggle room. Thus, these negative values are 4.5. This is high stuff. And then you have the height. This is you can have a comparison here. This one is a place, the whatever the theta is, you just has a factor multiplied by n, and then if you multiply n outside of the parenthesis, then you actually bump up the amplitude, or just flatten it, or it just stretches up or squishes down. So we can do a quick, just do a quick demonstration. Delete this part, and then we do just divide it by 3, maybe. Not too dramatic, otherwise it will, yeah, it's like this. However, at this point, it's just like being squashed down, and then we can multiply. Maybe we can put it also anywhere is fine, just outside of the parenthesis, because if you're putting inside of the parenthesis, it's actually increases the frequency, because inside is more associated with the frequency. So we move on to explain about the frequency part. This part, because we can check it, yeah, we multiplied it by a factor of 2. So this y, it takes like a 90, 180, which is pi, to reach and intersecting with the x-axis. However, if you are like multiply the theta value by a factor of 2, which means you increases the frequency, it will intersect with the x-axis at 90 degree. So that's how it is. And you can also divide it, so the frequency will be stretched out. Just divide by 2, and then we drag it down. So this part we can have an analysis that this one, the sign is having the intersecting occurred at the 180 degree. If we divide it, that means the frequency is actually not increased, the frequency drops. It's actually the intersecting point is at 360. And now we can do another experiment, just maybe not that dramatic. Maybe we just put a 1.5 in it, and yeah, and we can multiply it, just maybe multiply it by a factor of 6, and then drag it out. Yeah, it's very tiny. So you can also manipulate it by multiply by a factor of 10. Let's just check it out. Yeah. Okay, I guess I pretty much covered everything. We are rendering this effect and explain in Excel. The reason is because Excel is more accessible. As long as you have a computer, you can definitely plot it out using some simple stuff, because the data points are actually very simple to generate. You have a degree, and then you just control the interval. If you don't want any those points, if it's just a sparse populated points, you can increase the interval. If you want more points, you can just bump up the interval, or decrease the interval. Actually, you have more points. And then the critical part is just to turn the degree into radian, because everything is associated with it. Radian and the pi, you have a 2 pi r, that is the parameter, and then you have a pi r squared, then you have a like an area, and then you have a sphere, and you have volume is also associated with the pi. Pi is like more, and unit circle is also covered with the pi. So then and also the sine and cosine is calculated in terms of the radians. So you have this one and calculate it. So just be sure to convert the degree into radians, and then you have the calculations here. You have the y value, the x value is associated with the degrees, so you just lay it out as for visual effect. And then I guess other stuff, yeah, this is the magic of the unit circle. It just converts the radius and into the hypotenuse. Hypotenuse and the radius are both equal to 1, so you just substitution and simplify. It becomes the tangent parenthesis of theta equals numerator sine theta, and over the denominator cosine theta. This is how it is. And then you have how can I say it? You have a lag between sine and cosine. If you just increase, like at 90 degrees at the initial point, then the sine becomes cosine, and you have like amplitude. Amplitude is associated with height, which it can be realized by multiply the cosine value with a factor of n. As long as the multiplication is carried out outside the parenthesis, you will influence the height, which is the terminology is also called the amplitude. It can either stretches up or squashes down. That's how it is. And then you move on to the frequency part. The manifestation can only realize if you put the multiplication inside the parenthesis. That's why you have the multiplication inside it. However, on the opposite side, there's also true. You can divide it by a factor of 2 or divide it by a factor of 2 inside it. It's just you have a flatter. The frequency part, if you want more frequency, higher frequency, you need a multiplication by n. Anyway, you can also think of division as the multiplication of the reciprocal of the value. You can, for example, if we divide it by 2, we can think of the multiplication of 1 over 2 as the reciprocal of whatever the n you pass in. That's how it is. Okay, I guess this episode I pretty much covered everything. Okay, thank you, bye bye.